The second of our two concerns about our data was how close together or spread out the scores were, also called variability. Now that we know that deviation scores are a measure of variability, we may have a way to measure the average variability. So let's see if this will work. Each x-score varies from the mean. When the x-scores deviate from the mean by large amounts, there's a lot of variability in the distribution. When the scores are tightly packed together, there are small deviation scores. So the overall amount of measurement error or deviation is the variability of the distribution. Using what we know about averages, adding up scores and dividing by the total number of scores, to measure variability, it would seem a good idea to simply compute the average of the deviation scores. And this approach is called mean average deviation. For example, here are some data for the amount paid for a dinner for two on a college date. These are college students, so the values are small. Add them up, divide by n, and the mean equals 21. Now, subtract the mean from each data point. And here are the deviation scores. Let's put them into a table so that we can add up the sum of the deviations. It is at this point that we run into a problem. The sum of the deviations around the mean equals 0. When we divide by n, we get a variability of 0, and we know that can't be right. The reason that the mean was at the center of our distribution in the first place is because mathematically it lies equally far from all the scores above it and below it. So because the mean, or the center, lies equally far from the scores above it and below it, the deviation scores above the mean balance out the deviation scores below the mean. Therefore, the sum of the deviation scores, and by extension, the mean average deviation, will always be 0. And that is going to make it really hard to measure variability. But don't fret. Next time, when we talk more about variability, we will solve the problem of the mean average deviation always equaling 0 by magically making all of the deviations become positive. Actually, it won't really be magic at all. It'll be science. Magic is what people who do not understand statistics call math. But because you are learning statistics, you know better.